Hello everyone, welcome to Simplified Geometry. Today we are going to see Theorem 6.2 from the lesson Lines and Angles. We refer to this theorem as alternate interior angles. Before going to this theorem, let us understand the term alternate interior angles using this diagram. In this diagram, this is line M, this is line N, and this is line L. Line L is a transversal which intersect line M at point P, line N at point Q. The angles formed in between these two parallel lines is called interior angles. These interior angles are inside of these two parallel lines. These interior angles are inside of these two parallel lines. So here there are four interior angles formed. Here four interior angles are formed: angle 3, angle 4, angle 5 and angle 6. So we have listed out the interior angles from this diagram. Now let us take angle 4, which is on the top interior angle of the left side of this transversal. Then we must take angle 6, which is the bottom interior angle of the right side of this transversal. Hence angle 4 and angle 6 is one pair of alternate interior angles. You can see that angle 4 is on left side but top interior. Angle 6 is on the right side but bottom interior. Their positions are alternating. That's the reason it is called alternate interior angles. In the same way, angle 3 and angle 5 will form another pair of alternate interior angles. So we have found out the two pairs of alternate interior angles from this diagram. First pair is angle 4 and angle 6, and the next pair is angle 3 and angle 5. Now let us look at this theorem. This theorem states that if a transversal intersect two parallel lines, then each pair of alternate interior angles is equal. In this figure, if line M is parallel to line N with line L as transversal, then the pairs of alternate interior angles will be equal. We know how to find out the pairs of alternate interior angles. So just now we learned that if line M is parallel to line N, then the pairs of alternate interior angles will be equal. That means if line M is parallel to line N, then angle 4 will be equal to angle 6. This one pair will be equal. Then next pair will also be equal. Angle 3 will be equal to angle 5. This pair will also be equal, since these are alternate interior angles. Let us take an example. In this figure, line AB is parallel to line CD and PS is the transversal. Angle AQR is given as 40 degrees. This angle is on the left side and top interior. Then from the theorem we just learned now, angle QRD will also be 40 degrees. You can see that angle QRD is on the right side and bottom interior. So both these angles is a pair of alternate interior angles and they will be equal. They are alternate interior angles and they will be equal, since if a transversal intersect two parallel lines, then the alternate interior angles is equal. Similarly, if angle BQR is given as 140 degrees, then from this same theorem we can say that angle QRC will be 140 degrees, because both of these angles is also a pair of alternate interior angles. The reason we can write short in like this, alternate interior angles. There is an awesome tip for finding alternate interior angles. Here you can see line M is parallel to line N and this is transversal L. So the alternate interior angles will be equal. Angle 1 will be equal to angle 2. You can see that a Z shape is formed here. The letter Z has two parallel lines. This is a parallel line. These two lines are parallel. These two lines are parallel of this Z shape. You can see that angle 1 is enclosed in this corner of this Z shape. Angle 1 is enclosed in the corner of this Z shape. Angle 2 is also enclosed in this another corner of this Z shape. So we can easily find out the alternate interior angles using this Z shape. Here is also a Z shape. You can see that line X is parallel to line Y and line Z is the transversal. This is the Z shape here. So angle 3 is enclosed in this corner of this Z and angle 4 is enclosed in this corner of this Z shape. So angle 3 will be equal to angle 4. So letter Z will be useful for finding alternate interior angles. This is also a Z shape. This is also a Z shape. So the Z shape stands for alternate interior angles. And we can simply use the words alternate angles for alternate interior angles. Since this is a theorem, it has a proof. From the concept we have learnt earlier, we are now going to prove this theorem. Now let us look at this proof of this theorem. Before starting a proof, we must write what is given. So here it is given that line AB is parallel to line CD and PS is the transversal intersecting line AB at point Q, line CD at point R. Next we have to write what we have to prove. We have to prove that the pairs of alternate interior angles is equal. We can write that symbolically. So first we have to prove angle 4 is equal to angle 6. This is the first pair of alternate interior angles. So we have to prove that angle 4 is equal to angle 6. And the next pair of alternate interior angles is angle 3 and angle 5. So next you have to prove angle 3 and angle 5 are equal. And angle 3 is equal to angle 5. Now let us start the proof. So we have written the given information and then we have written the to prove, what you have to prove. Now let us start the proof. We will start from the given information. It is given that AB is parallel to CD and PS is transversal. This is given. We can see that angle 2 and angle 6 is forming a pair of corresponding angles. So when two lines are parallel, we know that the pairs of corresponding angles is equal. So angle 2 is equal to angle 6 because they are corresponding angles. So we have to write angle 2 is equal to angle 6. We should also write the reason. In brackets you have to write the reason. Corresponding angles axiom. So let this be equation 1. Now we can see that lines AB and line PR is intersecting at point Q. Line AB and line PR is intersecting at point Q. Then we know that the vertically opposite angles is equal. So angle 2 and angle 4 is a pair of vertically opposite angles. So when two lines intersect each other, then the vertically opposite angles are equal. So angle 2 will be equal to angle 4. So we have to write that lines AB and PR intersect at point Q. Then vertically opposite angles are equal. Angle 2 and angle 4 is a pair of vertically opposite angles. So angle 2 will be equal to angle 4. We should also write the reason in bracket. Reason is vertically opposite angles. Let this be equation 2. Now from both these equations, we can see that the left hand side is equal. Here also angle 2, here also angle 2. Then automatically the right hand side of the equation will also be equal. So automatically the right hand side will be equal. When LHS is equal, here angle 2 and here also angle 2, then the RHS will also be equal. Right hand side will be equal. So angle 6 will be automatically equal to angle 4. From equation 1 and 2. From equation 1 and 2, angle 6 will be equal to angle 4. Angle 6 will be equal to angle 4. First I will write angle 4. Angle 4 is equal to angle 6. So we have proved the first part. We had to prove that angle 4 equal to angle 6, and finally we have proved angle 4 equal to angle 6. So we have proved that one pair of alternate interior angles is equal. Similarly, we can prove in the same way. In the same way, we can prove that angle 3 will be equal to angle 5. So we will write similarly angle 3 will be equal to angle 5. So we have proved that when two lines are parallel, the alternate interior angles are equal. At last we will write hence proved.